Hi, hello everyone. In previous sessions, we discussed the concept, the singly linked list and its operations. Now we are going to discuss the another kind of the linked list, that is doubly linked list. Yes. After taking this session, you will be able to differentiate the singly linked list with doubly linked list, and also you will be able to create and display the contents of the doubly linked list. Let's see the definition of a doubly linked list, which is very similar to singly linked list, where the doubly linked list is also the group of nodes at the sequence of nodes. But unlike the singly linked list, it takes two reference fields. One is the previous node and another one to the next node. Just see the structure of a node where it is taking three fields. One is the data field. The next pointer, the next link holds the address of the next node, and previous link holds the address of previous node. Let's take an example. Consider a doubly linked list of three nodes where first node is located at the position 1000, where second node is situated at 2000 and third node at 3000. Just consider the first node which is located at the position 1000, where the data field we have initialized with the data value 10, coming to the next field which is holding the address of the next node. As this first node is having the next node further in the list, hence you need to store the address of the second node in the next field. Whereas coming to the previous field, the previous reference, where you need to make sure this must be the null, because as this is the first node, there is no previous nodes in the list, hence this must be the null. Whereas coming to the consider the second node, which is having both nodes, to left to the previous node and right side it is having the next node. In this situation, the next field should store the address of the next node, and whereas the previous field stores the address of the previous node. Yes. Now consider the last node, where here this last node is having the previous node in the list, hence the previous link should store the address of the previous node. Whereas coming to the next link here, as there is no next node further in the list, hence you need to make it as null. So here you should be very clear that the first node previous pointer must be the null and the last node next pointer must be the null. So here this indicates the first and last nodes in the list. Here the first node is called as the head node and the last node is called as the last node. Let's see the basic structure of doubly linked list as we discussed earlier. Here each node is taking three parts: the data part, the data part, the next pointer, and the previous pointer. Let's see the basic structure. Here declare a node structure with the help of a struct keyword, and declare a data variable, which is here I am declaring the data variable as of type integer. This can be of any type, that can be the integer or character or float or whatever it is. Now take the next pointer to hold the address of the next node, and in a similar fashion you declare the previous pointer to store the address of previous node. Just you should be very careful about these points. Here each node carries the data field and the two pointers. One is the next pointer to store the address of the next node, and the previous pointer to store the address of previous node. And here in doubly linked list, the first node is always pointed by head pointer and the last node is pointed by the last pointer. Here in each node a link is there to its next node, which is done with the help of the next pointer, and the previous node address we are keep tracking with the help of the previous pointer. And one more thing, the most important thing is you should make the previous field of the first node to null and the next field of the last node to null to indicate the first and last nodes in the doubly linked list. Now, coming to the advantages of doubly linked list, it is very easy to implement like this singly linked list. It is a dynamic data structure, and the most important thing is it allows the traversal in both directions. You can traverse the list from first node to last node, and as well as you will be able to traverse the list from last node to first node, because each node is holding the address of the previous node. And here the deletion operation can be performed efficiently compared to singly linked list, because no need to keep track the previous pointer, as each node itself is holding the address of the previous node. And reversing the list is very easy because each node is holding the address of previous node. Now, coming to the disadvantages of doubly linked list, it requires an extra memory because each node is holding three parts, three fields, one to store the data value and another two reference fields to hold the address of the next node and the previous node. Hence, it takes extra memory compared to an array and as well as compared to singly linked list. And one more, the most important thing is no direct access of any element is allowed because it is dynamic in nature. So the elements occupies the memory randomly. Hence, it is not possible to access the data in a sequential manner. Now, coming to the applications of doubly linked list, where here the doubly linked list we will use in any navigation system, that can be the music player or car or whatever it is, where we are trying to move either to forward or to the backward. And it is also used in many web browsers, like whenever you are performing the navigations by pressing the backward and forward buttons. In those situations, will take the help of the doubly linked list. And coming to the applications, like wherever you want to implement the undo and redo operations, in those situations will take the help of the doubly linked list. Now, coming to the operations on doubly linked list, in doubly linked list, we can perform the operations like creation, insertion, deletion, and traversal. Like singly linked list, whatever operations we have performed on singly linked list, all kind of operations we can do with the doubly linked list. Let's understand the creation operation on doubly linked list. Like singly linked list, the initial step is allocation of memory for node structure and refer that memory with the name n. Then assign a data value into the data field of n as n arrow data equal to 10 and make sure the previous and next pointers value must be the null. Like next arrow, the n arrow next is null and n arrow previous is null. Now, you make the new node as the head node and as well as the last node. This is the initial insertion. Inserting the first node into the list. In that situation, the newly inserted node will become the head node and as well as the last node. Now, insert the second node. Allocate a memory for the node structure. Insert the data value into the data field as n arrow data equal to 10 and make n arrow next as null and n arrow previous as null. This is the new node. Whereas previously in the list, we have another node with the name head and last. Now give links between the head and n. Like by making last arrow next equal to head. You should not move the head pointer whenever you want to do any operation with the last node. That should happen only with the last pointer. Hence, this name, the name of this field is last arrow next. Hence, this should hold the address of the next node, that is 2000. In a similar fashion, you need to give the previous pointer like n arrow previous equal to last. Here, this is the field of n arrow previous, which should hold the address of the previous node, that is last. Now, after doing this, then there are two nodes in the list, but the first node is pointed by the head and last, and the last node is pointing by n, where the last node is always referred by the name last. Then you need to make a move of last pointer from this position to this position by doing the simple assignment as last equal to n. Now insert another node, the third node. Allocate memory for the node structure. Insert the data value as n arrow data equal to 30 and make n arrow next equal to null and n arrow previous equal to null. Now make links between the last and n as last arrow next. So this should hold the address of the next node, that is 3000, and this position should store the address of the previous node, that is 2000. Like this. And then move the last pointer to the newly created node, that is last equal to n. This is the procedure to create the doubly linked list. Let's see the function here. First, allocate memory for the node structure and then read the data into the data field. Make the next pointer as null and then make the previous pointer as null. Now, initially, the initial condition, that means we can check for the list empty with the help of the comparison operator head equal to null. Head equal to null indicates the list is empty. That means you are performing the insertion for the first node. In that situation, you need to make the newly inserted node as the head node, and as well as the newly created node should be the last node by doing these two assignments. Now, for the next insertions, you need to give the forward pointer by using last arrow next equal to n, and then give the previous pointer by using n arrow previous equal to last, and then make last equal to n. This is the procedure to perform the creation operation on doubly linked list. Let's move on to the traversal operation. The traversal can be performed in two ways, that is in forward direction and as well as in the backward direction. Hence, this is also called as a bi-directional linked list. A doubly linked list is also called as a bi-directional linked list because it allows the traversal in both the directions, that is from the first to last node and as well as from last to first node. Now, consider an example of a doubly linked list which is taking three nodes situated at 1000, 2000 and 3000. The first node we are referring with head and the last node we are referring with last. Now, here the procedure is you should not move the head pointer and the last pointer. So that's why that kind of the movement we can do with the help of the temporary pointer. So just will traverse the list from the first node, hence assign, that means make the first node as a temporary node. Now print the temp arrow data, that is 10. After printing the temp data, now then move the temp to the next node. Now temp is pointing to the address 2000. Now print temp arrow data, that is 20. Then make a move of temporary pointer to the next node by giving temp equal to temp arrow next. Now the temp is moved to third node. Now print temp arrow data. Temp is referring to the address 3000 and the temp arrow data is 30. So this is the procedure to traverse the doubly linked list in forward direction. Let's see the function for display operation in forward direction. Start with the first node by doing the assignment temp equal to head till you reach end of the list. Just print the data value and then move the temporary pointer to the next node. Now, let us discuss the traversal operation in backward direction, in reverse direction, from last to first node. Consider the same example of doubly linked list with three nodes. With the first node, we are referring with the name head and the last node with the name last. Now, here initialize the last node with the temporary pointer, that is temp. Now print. The temp is now referring to the address 3000. Print temp arrow data, then it prints the data value as 30. Then move temp to the previous node by using temp equal to temp arrow previous. Now temp is referring to the address 2000. Print temp arrow data, which is 20. Again, make a move of temp to the previous node by following this previous link. Temp equal to temp arrow previous. Now temp is referring to the address 1000. Now print the data value at the location 1000, that is temp arrow data, which is 10. So this is the procedure to traverse the doubly linked list in reverse direction from last to first node. Let's see the function for display in backward direction. Start this traversal from the last node by doing the assignment temp equal to last. Now till you reach end of the list, print the data value of each node and move pointer to the previous node. So this is the procedure to implement the traversal operation in backward direction. Let's implement the creation of doubly linked list in C. Give a comment. C program to create and display the contents of doubly linked list. Include the required header files. One is stdio, for printf and scanf, and another one is stdlib for malloc. Now give node structure. 3 parts: the data, the next pointer, and the previous pointer. Now initialize head as null. Take the last pointer, the current pointer, and the temporary pointer. Now declare functions. One is create. The another one is display in forward and display the contents in reverse. Write the main function. Take a choice variable. Give menu options. One is for creation. And where 2 is for display. Now take do while. Read for choice. The scanf percentility ampersand choice. Then take a switch statement, pass the choice variable and select cases. Case 1, call create. Case 2, call display forward. Case 3, call display backward. Not backward, it is reverse. Now iterate till choice is less than or equal to 3. That's all with the main function. Implement create. Same procedure. Allocate memory. The struct node star. Typecasting. Use malloc to allocate memory dynamically. Compute the size of node structure by using size of. Now read a data value into the data field. Enter data that you store into an arrow data. And make an arrow next as null initially, as there is no next node, and as well as an arrow previous equal to null, there is no previous node. Now check for the first insertion. If head equal to null, you are making this new node as head node and as well as the new node as the last node. Now, for another insertions, just give the forward pointer as last arrow next equal to n and n arrow previous equal to last. Now this new node will become the last node, last equal to n. This is about creation. Now display contents of doubly linked list in forward direction. Just store the first node into temp, right? While temp not equal to null, just print each node and then move temp to next node. Now similarly, you do for reverse, void reverse, and then Start this from last. While temp not equal to null, printed data value, move temp equal to temp arrow previous. So that's all with the implementation. Let's see the execution. Here I change the printf statement with the 3 options: create, display forward, and display reverse. Let's see the execution. Where it is displaying 3 options: create, display forward, and display reverse. And we are giving the choice as 1. We are creating first node with data value 10. And again, we'll create a second node with data value 20. Create a third node with data value 30. Create a fourth node with data value 40. Create a fifth node with data value 50. Now I'll give the choice as to which print all the elements in forward direction from first to last node. See here, I have created 5 nodes and printing the information from first to last node. Now give the choice as 3. It prints the information from last to first node. The last node data value is 50, previous node, its previous is 40, its previous is 30, and so on. The first node is 10. So this is the implementation of the creation and display operations on Doubly linked list.